Okay, so we are going to construct a regular hexagon inscribed in a circle. So the first thing you want to do is draw a circle. So it really doesn't matter how large your radius is. Just make sure what you want to do is once you've decided where your circle is going to go, draw your circle nice and smoothly. And what's really, really important is we need to know where the center is. So I just like to take my compass and wiggle that compass point a bit so I can really see the indentation of the center. So you can kind of see that dot in the center. So I'm going to go ahead and mark that because I need to know where the center of the circle is, because the first thing we want to do is draw a diameter. So a diameter has to go through the center point, which is why we can't just guesstimate where that middle is. We want to find it. So it doesn't matter where you want to draw your diameter. You can go horizontal, vertical, slanted. It really doesn't matter. I'm just going to go kind of horizontal here. And what we want from this is we want the endpoints of the diameter, which I'm going to call A and B. And those are two vertices on the hexagon that we're creating. So if you remember, a regular hexagon has congruent sides, congruent angles. And then what's actually really neat is your regular hexagon is actually created or can actually form 6 equilateral triangles. And we're kind of using that idea here to do the construction. So let me show you the method. So hopefully you haven't changed your compass setting. If you did, that's okay. Go ahead and remeasure it. So we should be looking again at the length of this radius. And then what you're going to do is you're going to put your compass point on A and then swing your compass out to mark an arc on the circle. And what we've done here is we've created, basically, if we connect these 3 points from C to that intersection to A, we have an equilateral triangle because each of these sides is the length of one radius. So what's cool about that is, remember, each of these are 60. Our regular hexagon has an angle measure, interior angle measures that sum to 720. So all we have to do is basically put a second equilateral triangle there to get 120, which is the measurement of each interior angle of a regular hexagon. But anyway, I'm going off on a tangent. Let's go ahead and finish off the construction. So there's the first mark. What you can do is you can go ahead and move your compass onto that next intersection and mark it off a second arc. You can double check that this is in the right spot by putting your compass point on B and seeing if I swung it up, would I hit that same point? So that's how I know, okay, this is pretty accurate. Remember, we want to be very precise in our construction if we can. And then we can keep going. So now going from B downward, we're going to mark off another arc, scooching my compass point down here, putting off another arc, checking to make sure this is good. I'm checking to see if I reach A again, or I can turn this around and say if I drew an arc from A, will I hit that exact same point? I will. And now we're all done. So one compass setting, one circle, right? 6 points. There's my hexagon. So each of these intersections is a vertex of that regular hexagon. So just use your straight edge, connect your points, and we're done. So there's 1, 2, 3, 4, 5, and 6. So there's our hexagon. So each of these sides should be exactly the same. And like I said, this is also a great way to create an equilateral triangle. If I just connect any of my points to C, we bisect that angle and we get a 60-degree angle. So again, some things to think about. So again, that's a regular hexagon inscribed in a circle.